Hey everybody, my name is Emmanuel. I grew up right in Cranston on Reservoir Ave, and I'm a proud graduate of Rhode Island Public Schools. Um, I'm kind of a math guy. My doctoral degree is in transfer between mathematics and computer science, and I serve as the chief curriculum officer at a little research group called Bootstrap. So I'm here to talk to you about two different content areas that are available to Rhode Island teachers this year, and they're being offered both at the middle school and high school level. A little bit about Bootstrap briefly. So we are one of the larger providers of computer science nationwide. We reach more than 30,000 students every year. And while we're happy to be big, we're most proud of being diverse. So nearly 50% of our students are girls and young women. Nearly 50% self-identify as African American or Latino. And the reason that we have these numbers is that while we work with many, many computer science teachers nationwide, our bread and butter is bringing computing to the mainstream teachers that already reach every child. Both of our classes are soup to nuts materials. So that means we've got cloud-based software. It runs on literally anything with a browser, thoroughly detailed lesson plans. And when I say lesson plans, I don't just mean like an outline. I mean really detailed stuff, the kind of stuff you would write for a sub. Exit slips, do-nows, handouts. There's integrated student workbooks as well, because we believe that some of the best learning happens away from the keyboard, and supplemental activities as well. All of our standards are aligned to national and state standards for computer science as well as mathematics. And of course, if you need help after the PD, we do coaching throughout the year. We have a discussion board. We do site visits, conference calls, you name it. So all of these are available for both of the courses I'm going to be talking about. And both of these courses can be implemented as standalone computer science or integrated courses in mainstream classes. So I'll talk about how that works in just a moment. So the first thing I want to talk about is our Bootstrap algebra course. Now, of course, algebra is like the killer class nationwide. It's the most failed, most repeated class in the country. And for quite a long time, since basically 1960, we've known from groups like NCTM and math ed researchers that if you want to improve student understanding of algebra, you got to have students think about math structurally, right? Representations of functions that are concrete, not so abstract, and make these representations connected. And even though algebra itself is a 9th grade course, there's ample evidence that shows that if we change the way that we approach math in earlier grades, we can set kids up for success later. Now, Seymour Papert said, hey, programming could help, right? And so some of you all look pretty young, so I doubt any of you are old enough to remember a language called Logo. But going back about 60 years, people have essentially believed that if you learn to code, well, then that'll be good with math, right? Because coding and math, they have so much in common. And now that kids all over the country are programming, it worked, right? Everyone in America is getting A's in math. We can just pat ourselves on the back and go home. Yeah, not so much. So here's the thing about math and programming. If you want to teach math with programming, you want to make sure that your language has things like numbers, right? Because it would suck if a language didn't even have numbers. Well, guess what? There's a fabulous programming language called Java. It doesn't have numbers. We can do this audience participation style. In the Zoom chat, what do you think 1 divided by 2 is in Java? Feel free to type your answer. What do you think 1 divided by 2 is? We have a vote for 0, 2 votes for 0. Come on, guys, get serious. 1 divided by 2? 0.5, another vote for 0. Well, you know what? The zeros are correct. In Java, 1 divided by 2 is 0. Now look, there's a very good reason for that. And I'm not going to get into it because that was neither the time nor the place. But the point is, languages like Java, Python, Scratch, JavaScript, and so on, they make conscious design choices for high-performance programs that actually don't make any sense if your goal is math outcomes. And so you don't have numbers. It gets even worse when we get to variables. So here's a simple program I can write in Scratch or C or Python. The first line of code says x equals 10. Second line of code says x equals x plus 2. This is like programming 101, folks. But if you're a math teacher, or if you care about students understanding what variables are in math, this is just wrong. X can't equal itself plus 2. And so a kid who comes to my math class and says, I know variables, I've been programming, I'm thinking, which IEP does this kid need? And when it gets to functions, you don't even want to know, like vertical line test, schmertical line test. And so this is why historically learning to program has not benefited students in math. And what little evidence we have shows that programming can be problematic for student performance in math. So I'm giving you this crazy lesson. By the way, this is what my doctoral degree is. This is 8 years of research in one slide. I guess that was a good use of my money. But the point is that for Bootstrap, while we love computer science, our goal is very much focused on using programming that benefits math outcomes. And so we use programming languages that actually have numbers and variables and functions, and they reinforce the math rather than undermining it. Our approach is more than just about the language. Our pedagogy involves teaching structured problem solving. Our bread and butter is multiple representations of functions, whether you're dealing with numbers or pictures or animations. We embrace NCTM standards for best practices for teaching math, and all of our material applies equally well in the programming context and the math context. So in Bootstrap Algebra, so this is course offering number 1, students learn how to apply everything from linear functions to inequalities to the distance formula to build fully functioning video games that they present to their peers. Think of it as a science fair for the math department. And it covers a ton of math concepts, some of which start quite early. So if you're a 6th grade math teacher, the stuff we do for order of operations is going to be killer for helping nail down order of operations. We cover domain and range, function machines, linear relationships, inequalities, composition. Every problem is phrased as a word problem because that's where we want students to be successful. The whole curriculum is project-based. I have a few examples here. Kids build a flag using ratio, proportion, and geometric transformations to lay out shapes on a canvas to build a flag that matters to them. They can do the same thing to build a card, even an animated card when it's someone's birthday or Valentine's Day or the holidays. And of course, ultimately, they tie all of this math together to build a video game of their own design. So who is this course for? Like I said, we have a version of this that's appropriate for middle school grades and a separate one that's appropriate for high school grades. If you think there might be a lot of overlap between the two, you're right. Math, even though we teach it like some sort of assembly line, is much more connected than people think. And by using computer science to bridge those gaps, we're able to bring deeper learning for students. If you're a standalone CS teacher and you want to use your CS class as a double dose to help boost kids in math, you can use Bootstrap Algebra in your room. Your math teacher will thank you. But if you're a school that doesn't have a CS teacher, or maybe you do, but they've already got something else going on, you can integrate this material into your existing math class by simply changing the way you teach some of the content you already deliver. You don't need to find 25 new hours or 6 new months in your curriculum. As a former public school math teacher, we don't have that kind of thing. But because it's aligned to math, the programming behaves exactly like the math you were going to teach. And you don't need any prior programming experience to teach it, because as long as you're comfortable with math, you already know the way the machine works. The second course offering I'm here to talk about is called Bootstrap Data Science. And I'm not going to go into as much detail as I did for algebra. I'll simply say this. Data science is the latest hype cycle. Everyone is hearing a lot about it. Rah, rah, data science, it's the best thing since sliced bread. But no one's really talking about what it means. And so the Bootstrap definition for data science involves, think of 4 core ingredients for a recipe. Yes, you need some math. You need the statistics and the mathematical rigor to perform your analysis. Yes, you need computing, because something that's unique to data science is doing this analysis over large data sets that would be impossible to analyze by hand. But there are 2 other ingredients in this recipe that are often left out. One is called civic responsibility, because if all you think about data science is that it's math plus code, great. We'll teach kids how to take a good random sample, that's math, and we'll scrape, I don't know, random comments on YouTube videos. That's programming. Of course, if you've read comment threads on YouTube, you know it's basically a toxic cesspool of the worst parts of humanity. And so what this third ingredient is about is saying, look, it's not enough just to think of math and code. You have to understand that taking a random sample from a population filled with bias already is problematic. And so if we want to build machine learning algorithms to do things like, I don't know, make recommendations for mandatory minimum sentencing, decide who gets parole, decide who gets pain medication. These are things that require more than just math and code. And for students who may not see themselves as computer scientists or mathematicians, this is incredibly important because it deals with how data science affects them and the people around them. The fourth ingredient is domain investment, because students should be able to analyze data in a domain that matters to them. In the same course, you could have a kid who's like a football nerd who wants to figure out how quarterback rankings are calculated, and another student who's really interested in roller coaster fatalities. Those two students can analyze the domain of data that matters to them, both using all of the standard complement of data visualization, measures of center and variation, and threat stability. So those are the core ingredients of the Bootstrap Data Science course. I did want to share, I mentioned roller coasters. We have a roller coaster data set. This is an actual student final project. This student analyzed roller coasters around the country using one of our data sets. She built a number of subtables. She displayed pie charts, bar charts, histograms. She looked for correlations in her data and found an interesting observation about the difference between wooden and steel roller coasters. I should add, by the way, this student was an underperforming 10th grader in California who was pushed out of Algebra 2 and found that she was excited by this data and interested in doing something rigorous. So this is just an example of one of the final projects that students create. The full course covers a ton of middle and high school statistics standards, as well as the programming necessary to implement them. And students build infographics, they design surveys, they write research papers. We even have an evil research paper project where students learn how data can be misreported or manipulated. And they create evil versions of their papers, and then they swap with a friend. And the goal is, can you figure out how your friend misused data science to draw manipulative conclusions? Kids have a lot of fun with it. They love trying to sneak slime past one another. And ultimately, they learn how to become critical consumers of data. Again, this is available for middle and high school. If you're looking to do a standalone CS class, we have a full curriculum for you, but this can also be integrated in a modular approach to math and statistics classes. Science classes, if you're a science teacher who has students gather data, have them analyze it in a rigorous way. And a surprising number of social studies and history classes use elements of data science to look at trends in population, voting patterns, and so on over time. Like Bootstrap Algebra, we use a mathematical language that does not require any prior experience to teach. Our trainings are 40 hours spread over 5 days. They're totally hands-on. You are in the role of a student trying out the activities. You complete the final projects, and you run into the same questions and mistakes students will, so you have a chance to see the pedagogy model for how we respond. And of course, we don't just leave you at the PD. We've got coaching throughout the school year. If you're interested and you'd like to learn more, here's our website. We have a number of PD offerings over the summer, and we're happy to work with anybody from my home state of Rhode Island.